Hello, so today we are going to do this problem from Leetcode Daily Challenge, can place flowers. So basically we have a flower bed, which is just a place where you can put flowers. And there are some plots that are planted, others are not. And what we want is to place flowers where no adjacent ones have flowers planted, right? So we need one planted, one not planted, one planted, one not planted, right? And so it basically would represent 0 when it's empty and 1 when it contains a flower, right? And so we don't want two adjacent ones. That's essentially what it is. And we get as input value n, and we want to return true if we can place n flowers such that no two are adjacent. And we will return false if not. So for example, here with one flower, right, that we want to place, we can place it here. That way, this one is empty, this one is empty. So no adjacent ones. There are no adjacent one with value 1. And so here it's possible, so we return true. Now with 2, we can't, because if we put one here, we have only two choices, either here or here, and whichever one we choose will end up with adjacent ones, and so we return false, right? So that's roughly the idea. Now this should be easily solvable with just like doing literally what the problem asks us to do, which is just checking if the adjacent ones have so let's say, for example, here, if we take this one, what we can do is just go through the array like this, and just for each I, check the left and the right. If any of them contain 1, we don't place anything. We keep n as it is. But if both adjacent ones, I minus 1 and I plus 1, have zeros, then we can place. And so we place and we just decrement n. So what that would mean, for example, in the first test case with n equal to 1, the first iteration we are here. So the adjacent one is just I plus 1, because I minus 1 is not there, so we don't handle it. But this one is 0, but the value itself is already 1, so we should skip. Now this one, the adjacent one, I minus 1 is equal to 1, so we skip. So now our I is here. Now I minus 1 has 0 and I plus 1 has 0, and the value at I itself has 0. So now we could use this one, and so we actually need to put 1 here, decrement n. And why do we put 1 here? Because so that we don't end up putting 1 here. If we don't mark it, then we will go, let's say if n equal to 2, then we'll place 1 here, but we shouldn't, because we planted in the previous position, right? But here, as soon as we find that n is equal to 0, we can just return true, because we were able to place it, right? And then if at the end n doesn't reach 0, then we can return false. So that's roughly the idea. So let's implement it. So we need the length of the flower bed first. So let's just have a variable for that. And then we will just go through the range of L, right? And now what we will do is we can just check if first the position itself has to be 0, because we can't plant in something that was already planted. The other thing we need to do is, if flower bed of I minus 1 needs to be, the adjacent ones need to have 0. So both I minus 1 and I plus 1 needs to have 0. Okay. Now there is one edge case we need to handle. What if we are actually in position 0? Then I minus 1 doesn't exist. So in that case, we want to say either it's 0 or its value is 0. So if it's 0, we don't need to check to the left. There is nothing to the left. Same thing here. If it's the last one, we don't need to check to the right, because there is nothing to the right. So here we can just say I equal to n minus 1 to L minus 1. That's the length. Or I plus 1 is equal to 0. And so here in this case, we can actually place at I, we can place 1, because adjacent ones are 0 and the value itself is 0. And we can subtract from n, because we just placed 1. Now, if at any point n is equal to 0, we should be good. We were able to place what was required. And if we went through the entire flower bed list and we weren't able to place all n values, we can return false here. So this we can do it just n needs to be equal to 0. Now we could also return false, but the problem there is that what if n is equal to 0, where we don't need to place anything? So we just need to make sure from the input n is equal to 0, right? And so we want to handle that, so we can just return n equal to 0. And that should be it. So let's run this. Looks like there is one edge case here where n equal to 0 returned false. So one thing we want to actually do here, just one correction, is that if n is equal to 0, we shouldn't go through this even, right? So either that, we can do it at the beginning like this, if n equal to 0, then just return true, or the other way to do it, because maybe we ended up subtracting here, then we want to do n less than or equal to 0, right? So whichever one you want. Now if we run this, it should pass. Let's submit. And this works, okay? In terms of time complexity, this is O of n because of this just for loop. O of n time. Space, we are not using extra space, so O of 1 space. There is a way to actually make this a little bit better and simplify the edge cases. So how do we do that? Well, the first one is we want to get rid of this I equal to 0 and I equal to L minus 1. So how do we do that? Well, the easiest way to do it is to just pad to the left and to the right, add padding with zeros, right? Basically, because we want this, when I equal to 0, we want the left to be as if it was equal to 0, right? Because we can consider that there is no adjacent one to the left, right? And similarly to the right. So that's what we do here. Now we don't need to check I equal to 0, but we need to start just from 1 and start from and at the last, before the last position, because before the last position is something we just added, and the 0 position is something also we just added, right? So that way we only need to check the real value of the original flower bed. And so here, now we don't need to check this anymore because we are just starting from 1, and same thing here, we don't need to check that anymore, right? So this padding here simplifies our logic. The other thing is that all we are doing here is just checking that there is no value 1 in the range I minus 1 to I plus 1. We are just making sure that there is that 1 is not in this range. We want them all to be equal to 0, which means 1 should not be there. So let's just do that. So 1 not in flower bed from I minus 1 to I plus 1. In Python, to do to I plus 1, we have to do I plus 2 here. And so that's a way to simplify this. And then the rest can be pretty much the same, and we can just run this. And this looks good, passes. Yeah, so this simplifies a little bit the handling, the logic handling. Yeah, so that's pretty much it for this problem. Please like and subscribe, and see you on the next one. Bye.